All right, this video is going to go over pages 18 through 21. So last video we talked about a little bit about reflection. So when it hits something like a fixed end, it's going to come back inverted. If it hits a free end, it's going to come back right side up. Okay, so now we're going to talk about is what happens when we send a wave or a pulse down and we change medium along the way. Okay, so our first example is going to be a less dense to more dense. Okay, so we're actually sending a wave down towards the more dense side. So when you run into a more dense side, that's going to act like a fixed end. Okay, so it's going to be something that wants to inhibit your motion. Okay, so think of like this. My example, I can think of this is you're running along on land, and then you try to run, like you run down the beach, and as soon as you get into water, are you able to run as fast as you could on land? No, because you're changing medium up, where now you're running in a more dense medium, so you can't run as fast as you can. So that's trying to inhibit your motion. So that's kind of a way I think about that. So let's look at an example is if we send an incident pulse. So remember, our incident pulse is the one that's going down, okay, the one we send. Okay, we're sending it towards a more dense medium. We're going to see, well, what happens? Okay, well, naturally, some of the wave is going to continue to keep going in that more dense medium. So let me switch up the size here. So some of that energy is going to keep going in my new denser medium. Okay, so not as much. Okay, remember amplitude's energy. So think about is, do you have that same amount of energy, or could you have that exact same velocity and stuff like that whenever you run in water versus land? No. So some of that energy is going to get dissipated, okay, because it's a more dense medium. Okay, so even though it's there, okay, it's not going to be, the amplitude's not going to be as big because the medium is harder to transfer that energy into. Okay, so it's going to be it's going to be right side up. Okay, so it's going to keep going. Let me switch up the size here. So this transmitted pulse, okay, so that's what transmitted pulse is. It's the part of the wave that keeps going in a new medium. It's going to keep going. Okay, it's right side up. It didn't change anything there. Okay, it's just going to keep going however long it needs to. Now, when you hit a different medium, okay, that's called a boundary. Okay, so some of that wave is going to keep going, but some of it is going to naturally reflect back. So it goes both ways. Either you're going from less dense to more dense or more dense to less dense. Some of that wave is going to be reflected back. Now, the key is, what's the amplitude going to look like? And then is it going to be right side up? Okay, or is it going to be inverted? Okay, so when you hit a more dense medium, okay, what's going to happen is more dense is going to try to inhibit you. So we're going to say that's kind of like a fixed end, where the fixed end is trying to stop the motion. Okay, the more dense is kind of doing the same thing. So what's going to do is it's going to send back some of the wave. Okay, not near as much as what we had in the beginning. Okay, so remember, some of that energy kept going into the more dense rope, and some of it's going to come back. Okay, but it's going to be inverted. Okay, so some of this is going to come back. Your amplitude is not going to be as high as your original amplitude, because some of that energy kept going this way, so right here. Okay, some of the energy kept going this way, and then some of the energy is coming back inverted. Okay, so that's why those amplitudes aren't near as high as what they were in the beginning. Okay, so what's going to happen is, naturally, if your amplitude is going to get bigger like that, what's going to happen as soon as you hit that more dense medium, your wavelength is going to decrease. Okay, so this is probably the trickier part, because what we've been talking about prior to this is, well, if wavelength decreases, that means frequency is going to increase. Now, that's for something that's like continuous waves, okay, like radio, light, things like that. Okay, but what these are pulses that are sent down by a source. Okay, so like it could be human. Okay, so if you wanted to send a pulse down the rope, that means honestly the frequency would depend upon the source. Okay, so frequency will depend on the source. Okay, so like if you had a rope and I said, hey, send one wave down, that would be your frequency. Or if I said, hey, send 3 waves down, okay, that would be your frequency then. So it's kind of controlled by the source here. Okay, so our wavelength is going to decrease, but our frequency is going to stay the same, okay, unless we change the source. Okay, so now that's as far as reflected pulse and transmitted pulse, that's what that would look like. Now, velocity, so we kind of talked about this, think about how fast you can run in air versus water. Okay, so if you're going from air to water or less dense to more dense, velocity is going to decrease when you transmit to that more dense medium. So the velocity, once it hits that thicker rope, is going to slow down. Okay, so This part is going to slow down. Let me switch colors up real quick. So this wave is going to slow down because you're in a more dense medium. Okay, now this one, that reflected pulse didn't change mediums from the original pulse. Okay, so that velocity is going to stay the same. Okay, so remember, the only time you can change velocity is by changing medium. And the reflected pulse didn't change medium, so it's just going to be the same velocity as the incident pulse or the incoming pulse. So that is going from less dense to more dense. Now let's look at the opposite. Let's go from more dense to less dense. So when we go from more dense to less dense, think about it, it gets easier. Okay, so it kind of acts like a free end. So nothing's really inhibiting you. It actually gets easier for you. Okay, so think about that when you're starting to think, is it going to be reflected? Is it going to be upright? So it's not really inhibiting my motion. It actually makes it easier. So what we're going to do is we're going to send an incident pulse down towards this less dense rope. Okay, and we're going to see what happens. Okay, so what's going to happen is part of my wave is going to transmit. Okay, so it's going to keep going. Now you got to think about how much energy you have in this thick rope right now, and think about when that transfers to something easier. Okay, so that energy is basically going to take off. It's going to be a lot easier for it. So that amplitude is still going to be upright, but actually the amplitude is going to be a lot bigger than the original amplitude. Okay, so your transmitted pulse is going to be bigger, okay, because you went to a less dense medium, so that energy transferred, and it's a lot easier for that energy to transfer in an easier or less dense medium. So that amplitude is bigger. Now, the part that comes back, so even though it's going from a more dense to a less dense, there's still that boundary in between, okay, that's going to send some of it back. Okay, and since you're going from a more dense to less dense, that's not really inhibiting it. So the part that's going to come back is going to be upright. Okay, so this is going to be coming back the opposite way. Okay, if you noticed, your amplitude is smaller, okay, which makes sense. A good chunk of the energy kept going on, and it transmitted into the new medium, and then a little bit kept reflected back. Okay, so you're not going to have it near as much amplitude as what you had in the beginning. Okay, so the amplitude is going to be smaller on the reflection. Okay, so now let's take a look at as far as velocity goes. So think about if you go from a more dense to a less dense, okay, so this velocity here is going to increase. Think about all of a sudden you were running in water and now you're not. Okay, so all of a sudden it's a lot easier medium, it's less dense, so you can move a lot faster. Okay, so you'll have higher amplitude, higher velocity when you go to that less dense medium. And then this velocity here will not change again. Okay, so that reflected pulse is still in the same dense rope, so nothing changed there, so velocity is still the same on the reflected pulse. Now, your wavelength is going to increase, okay, on that transmitted pulse, so wavelength's going to get longer. Okay, and remember, frequency is controlled by the source here. Okay, so unless we change the source, frequency is not going to go up or down. So as far as velocity goes, so if you're going from a more dense to less dense, so think about running in water and now you're running in air, okay, your velocity is going to increase when you transfer or transmit to that less dense medium. Okay, so let's do a little practice. So we're going to do, case one is where you're going from more dense to less dense. Okay, so one, the reflected pulse in medium one will or will not be inverted. Okay, so remember when we go from a more dense to less dense, it acts like a free end. So some of this is going to be reflected back and it's going to be upright, okay, because it's inverse. Okay, so will not be inverted. Okay, because less dense acts like a free end. Okay, so it's easier. It doesn't try to inhibit its motion at all. Okay, so it's going to act like a free end. Now, the speed of the transmitted pulse will be greater than, less than, or same as the speed of the incident pulse. So you changed mediums, so your speed cannot be the same. It won't be the same. Okay, so it's either going to be faster or it's going to be slower. Well, you went from a more dense to less dense, so it's going to get easier. So that is going to be greater than. Now, the speed of the reflected pulse, okay, so I'm sorry, I could have drawn a transmitted pulse. Your transmitted pulse would look like this. Okay, so that's going that way. The reflected pulse is going that way. Okay, so the speed of the reflected pulse will be greater than, less than, or the same. Well, the reflected pulse stayed in the exact same rope, so it's not going to get faster or slower. It's going to stay the same. The wavelength of the transmitted pulse will be greater than, less than, or same as. So that wave got bigger. Okay, so our wavelength is going to be greater than the original incident pulse. The frequency of the transmitted pulse will be greater than, less than, or same as the frequency of the incident pulse. So remember we talked about frequency is dictated by the source. So unless we change that source, your frequency is going to stay the same. Now let's do case number 2 where we go from a less dense to more dense. Okay, so remember, so part of that wave is going to transmit. It's not going to be near as much, okay, because you're going to a more dense medium. Okay, and then part of that wave is going to reflect back. Okay, but you go from a less dense to more dense, that's going to get harder. It's going to try to inhibit your motion. So that wave is going to come back inverted. Okay, and it's not going to be near as much as it had in the beginning. Okay, so your transmitted pulse is going this way, your reflected pulse is going that way. So the reflected pulse in medium 1 will or will not be inverted. It will be inverted because your more dense is acting like a fixed end. More dense is acting like a fixed end. Okay, the speed of the transmitted pulse will be greater than, less than, or the same. So you went from a less dense to more dense, so it's not going to go faster. What it's going to do is it's going to slow down. Okay, it gets a lot harder to travel in that more dense. The speed of the reflected pulse, so remember your reflected pulse didn't change mediums at all, so it's going to be the same. The wavelength of the transmitted pulse, so that wave got smaller, so that wavelength is going to be less. Okay, and then your frequency of the transmitted pulse, remember frequency doesn't change unless the source changes, so frequency is going to be the same. Okay, let's look at our last bit is with reference to the diagram above. A pulse is sent along a thin rope attached to a thick rope. The thick rope is in turn tied to a wall. Okay, so in this case what I'm seeing basically almost 2 fixed ends. When you go from a less dense to a more dense, that acts like a fixed end. And when you actually have something tied to a wall, that literally is a fixed end. So what happens when the pulse reaches point A? Okay, so instead of writing this out, what I'm going to do is I'm going to kind of just draw this out. Okay, so what's going to happen is part of that pulse is going to keep going, and it's upright. It's not going to be near as much. Okay, so that's going to stay upright. Okay, and then part of that pulse is going to reflect back. Okay, so it's going to come back along here. And since you went from a less dense to more dense, that's going to try to inhibit you, so it's going to actually invert your wave coming back. So you're not going to have as much of a wave coming back, and it will be inverted. Okay, so that's your reflected pulse, and that is your transmitted pulse. Okay, so then it says, what happens as it reaches point B? Okay, so point B, that's another fixed end. So what's going to happen is that wave, that transmitted pulse is going to hit that wall, and it's going to come back inverted the opposite way. Okay, so that's going to come back inverted. And then what's going to, you could keep going further with this, is what would happen to it if it hit point A. Okay, at point A, it would stay in the same direction. It would stay in that same downward direction. I'll draw it in a different color. It would still stay in the same down direction, okay, because remember when you go from more dense to less dense, it's not going to invert it, and your amplitude is going to go back up, okay, because you just went from a more dense to less dense. Okay, so, and we'll do more practice on this as far as the review goes and stuff, and then over the next couple of pages, but that'll be it on this one.